Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about adding and subtracting rational expressions.
Minute Math. When you need help, you use Minute Math.
We're given this problem right here, u minus v over 8v plus 6u minus 3v over 8v, and we got to simplify this expression. Now notice we have the same base here for each one of our expressions, or rational parts, right? Expressions here. So since they have the same base, we can add them under one big rational expression. We have an 8v still in the denominator. And to show it here, we have u minus v plus our 6u minus 3v. Now from here, we can combine our like terms in the numerator. So u and a 6u turns out to be when added, a 7u. And a minus v and a minus 3v is a minus 4v. And that's going to be over an 8v. And from there, we really can't simplify anymore. And so our final answer here is 7u minus 4v over 8v. We're given this problem right here, m minus 3n over 6m to the third power n minus m plus 3n over 6m to the third power n. And we gotta simplify this. Well, first thing that's great is these two fractions have the same denominator, 6m to the third power times n. So we know we can instantly combine them to be one big fraction, with a denominator of 6m to the third times n. The numerator, we're just going to subtract the 2, so let's write it out here as m minus 3n minus m plus 3n. Then from here, we want to combine our like terms. So let's rewrite some of this is going on. So I'm going to distribute this minus sign to both parts here as I go. So we have m minus an m here, then we have a minus 3n here, and then a minus 3n. And that's going to be over a 6m to the third power n. Well, combining our like terms again, we have m minus an m cancels each other out. It's going to be 0. So we have negative 3n minus 3n, which is a negative 6n in the numerator. In the denominator, we have a 6m to the third power n. But we're not done. What can we cancel out? Well, the 6's cancel, and the n's will cancel. And so we're left with a negative 1 over an m to the third power, and that is our final answer. We're given this problem right here, 5 over a squared plus 3a plus 2 plus 5a plus 1 over a squared plus 3a plus 2. We gotta simplify this. Notice we have the same denominator here for both of these fractions. What does that allow us to do? Well, it allows us to combine them to be one fraction with that same base. A squared plus 3a plus 2. Then we have to add the numerators. So we have 5 plus a 5a plus 1. And this one's actually fairly simple now. We need to combine our like terms. So in our numerator, we have, well, it's all addition here. So we just have a 5a first. And then we have 5 plus a 1, which is a 6. And that's going to be over our a squared plus 3a plus 2. And there's actually nothing more that we can do to simplify this. And so our final answer here is 5a plus 6 over a squared plus 3a plus 2. We're given this problem right here, 5 over 10n squared plus 16n plus 6 plus n minus 6 over 10n squared plus 16n plus 6. And we gotta simplify this expression. Well, first thing I notice, we have the same base here for both of these fractions. So that means we can combine this to be one larger fraction with that base. So we have 10n squared plus a 16n plus 6 in the denominator. Now the numerator, we just add it like we normally do, 5 plus an n minus 6, like so. So where do we go from here? Well, our denominator we keep the same, let's leave that there. Our 10n squared plus 16n plus 6. The numerator, we combine our like terms. 5 and a negative 6 add together to be a negative 1. We just have that n come down. And we're basically done here. There's nothing else that we can do to simplify this. And so my final answer is just a negative 1 plus n over 10n squared plus 16n plus 6. We're given this problem right here. r plus 6 over 3r minus 6 plus r plus 1 over 3r minus 6. And we got to simplify this expression. Beauty of this expression is that we have the same denominator for both fractions. So we have the same denominator, we can write this as just one big fraction right off the bat with the same denominator, 3r minus 6. The numerators, we just add r plus 6 plus r plus 1. So now let's go combine our like terms. We have our r's. r plus 1r is a 2r. 6 plus a 1 is a 7. And that's going to be all over a 3r minus 6. There's nothing else that we really can do to simplify here, and so our final answer is 2r plus 7 over 3r minus 6. We're given this problem right here, x plus 2 over 2x squared plus 13x plus 20 minus x plus 3 over 2x squared plus 13x plus 20, and we got to simplify this. Well, notice we have the same base for both parts here, or denominator. So because we have that, we can combine it easily. 2x squared plus a 13x plus 20 here. Then we have to, by having that same denominator, we just add the numerators, or subtract them. We have an x plus 2 here, minus an x plus 3. So we now want to combine the numerator. So the denominator keeps the same, 2x squared plus 13x plus 20. But the numerator, make sure we combine our like terms. Make sure we distribute this subtraction sign. So we have an x right here minus that x. Then we have positive 2 minus the 3. So now we combine the like terms. X minus x is a 0. Don't need to write that. And 2 minus 3 is a negative 1. Denominator stays the same. 2x squared plus 13x plus 20. And we now have our final answer here. Negative 1 over 2x squared plus 13x plus 20. We're given this problem right here. 6 over x minus 1 minus 5x over 4. And we got to simplify this. Well, notice we don't have the same denominator here. So to simplify this, we have to come up with the same denominator. So I'm going to rewrite this 6 over x minus 1 with some space and 5x over a 4. Well, if I multiply the right-hand side by a x minus 1 over itself here, that denominator, and then take my left one and multiply with this denominator, 4 over 4, we're essentially just multiplying by 1 here, right? 4 over 4 is 1, x minus 1 over x minus 1 is 1. But what that allows us to do is come up with the same base. So let's go simplify the numerator here. 4 times 6 is a 24, and we have a 4x minus 1 here. Then we're subtracting 5x times an x minus 1. We distribute this out. We have a minus here. And 5x times x is a 5x squared, and 5x times a minus 1 is a minus 5x. But that's over 4 times an x minus 1. We now have the same denominator, so we can combine these. Denominator being 4 times an x minus 1 here. And then our numerator is 24 minus the 5x squared minus 5x. Okay? Now, we can simplify this just a little more. We can rearrange it if we want. We put the negative 5x squared out front. Negative 5x squared here. Then make sure we're distributing this. Negative, negative makes it positive, positive 5x. And then we have a plus 24 here. That's over denominator 4 times an x minus 1. And so our final answer here is a negative 5x squared plus 5x plus 24 over 4 times x minus 1. We're given this problem right here, 6 minus x plus 5 over 7x minus 5 times x plus 4, and we got to simplify this. Well, the main thing here is these do not have the same denominator. 6 has a denominator really of 1. And the second part is, this multiplication, 7x minus 5 and an x plus 4. So to have the same denominator, I'm going to rewrite this first part here to be 6 times that 7, if I can write 7x minus 5, and we have an x plus 4 here, over that same thing, 7x minus 5, x plus 4. The right-hand side stays the same, it's the same denominator. And there's a 1 here, right? 6 over 1, but we don't need to write that. And we have a 7x minus 5 and an x plus 4. In the numerator, we just have the x plus 5. So now, what we have to do is, well, we can simplify this, combine the like term, the same denominator, the two parts here, that same denominator. So we can combine that, and in doing so, we'll also simplify some of the numerator. So 7x minus 5 here, and an x plus 4 all together as one fraction. Let's go multiply all this out. And in doing so, 7x times x is a 7x squared. Then 7x times 4 is a 28x. Negative 5 times x is a negative 5x. And negative 5 times 4 is a 20. So negative 20 here. Okay? Then we still have to subtract that x plus 5 and make sure it's in a parenthesis there. Continuing on this good old curve here, distribute the 6 across to all parts here. Well, as we combine it, okay? Oh, it's itchy. Well, actually combine, sorry, missed a step here. These two together come at 23x, right? 28x minus 5x is 23x. So 6 times 7x is a 42x squared, or 7x squared. 6 times a 23x is a 138x. Then 6 times a negative 20 is a negative 120. Then we still subtract an x, distribute that out, and subtract a 5. All over that big old denominator, 7x minus 5, we have an x plus 4. Well, lastly here, let's put it right here. Let's combine our like terms. We have the x and the negative x and 138x, and then negative 20 and negative 5. So 42x squared here, plus 138x minus 1x is 137x. Negative 120 minus 5 is a negative 125. And our denominator stays the same, 7x minus 5 and x plus 4. And so our final answer here after all that is 42x squared plus 137x minus 125 over 7x minus 5 times x plus 4. We're given this problem right here, 3 over x plus 7 plus 4 over x minus 8, and we have to simplify this expression. Now, notice here that we do not have the same base for each fraction. So we need to get that. So I'm going to rewrite this out here, little space here. We have an x plus 7 here, and we have the 3. And we have the, well, x minus 8 here, and we have the 4. But we need these denominators really to look the same. So I'm going to take this denominator, x minus 8, I'm going to multiply it on this side here and up here. And notice we can cancel each other out, and it really doesn't change the this part of the expression. Same with here. We have an x plus 7, and put it over here, an x plus 7 as well. What we notice is we now have the same base. X plus 7 times x minus 8. X minus 8 times x plus 7. What that allows us now to do is we can write this as one fraction, x plus 7 over an x minus 8. Now we have to distribute here as well. We multiply that out. So 3 times an x is a 3x, and 3 times an 8 is a 24. Do the same thing here with a 4. 4 times the x is a 4x, and a 4 times a 7 here is at 28. Now we have to combine our like terms in the numerator. We have the 3x and 4x, that gives us a 7x here, and a negative 24 and a positive 28 is a positive 4. Put it over our denominator, x plus 7, and we've got x minus 8. And so that's it. Our final answer here is 7x plus 4 over x plus 7 times an x minus 8. We're given this expression right here, 3 over 4v squared plus 4v minus 7 over 2. We have to simplify this expression. We do not have the same denominator here for both parts, so we need to get that. What I'm going to do in this first part is I notice that if I pull out a 2 here from this denominator, I'm left with a 2v squared plus a 2v. But I did that because I see there's a 2 in this denominator. So this denominator here is, well, a 2, and then there's a 7. So if I multiply, right, this second fraction by what's left over here, 2v squared plus 2v, over itself, 2v squared plus 2v, we now have the same denominator here for both parts. So now with that means we can combine these fractions to be one big fraction. So let's go do that. Our denominator here, we have a 2 times a 2v squared plus 2v now in our denominator. And then our numerator, we still have that 3 minus. Now, we distribute this right here. When we distribute that over, we'll keep it one big fraction here. Minus 7 times 2v squared is a 14v squared. And 7 times a 2v is just a 14v. Okay, so we're distributing it there. Don't forget that minus sign. Now continuing on, the numerator, we can distribute this minus sign. So we have 3 minus a 14v squared, and then distribute that minus sign again to a minus 14v. The denominator, I can still pull out a 2v here from the denominator, right? So if I pull out a 2v and I multiply it by 2, I got a 4v, and I'm left with a, just 1v here, and then plus 1. Remember, we're pulling out that 2v from both parts here. And so basically this is pretty much simplified. And so our final answer is 3 minus 14v squared minus 14v over 4v times v plus 1. We're given this problem right here, 7/3 minus 8 over 12x minus 8, and we have to simplify this expression. Well, we know we have to have the same denominator to add these fractions together. So I'm going to rewrite this 7/3 like this, give us some space, subtracted by 8 over 12x minus 8. But how do we have the same denominator? Well, I'm going to take this first fraction, 7/3, and I'm going to multiply it by a 12x minus 8 over itself. So I'm going to take this denominator and write it over itself, and it'll be multiplied. I'm going to do the same thing here with this denominator being the 3. Multiply both sides of the top and the bottom by 3 over 3. What does it have? Well, our denominator is now 3 times 12x minus 8, meaning that we can combine that to be one larger denominator. Okay? So, following my steps here, I'm going to do that. And as part of it, I'm going to multiply this numerator out. So 7 times a 12x is an 84x, and 7 times minus 8 is a minus 56. Same thing here, 8 times 3 is 24, so we subtract 24. Our denominator is just at 3 times a 12x minus 8 here. Okay? Keep on going, all right? We can keep simplifying here. We can combine our like terms in the numerator. We have negative 56 plus a negative 24. That's a negative 80. So we have an 84x minus 80 over, down here in the denominator, I can pull out a 4 here. So if I pull out a 4 from both parts, and I watch this, I'm going to keep it separate. 3 times a 4, pull out a 4, I'm left with a 3x minus 2. Now, we're not done yet. I can put this over here a little bit. We have 84x minus 80, right? That, we can pull out a 4 as well. If I pull out a 4 from the numerator, I'm left with a 21x minus 20 over, again, that 3 times 4 times the 3x minus 2. Notice now the 4's will cancel here, just trying to get a little more simplified. And so moving downwards now, going everywhere here, we have a 21x minus 20 over a 3 times a 3, if I can write a 3x minus 2. And that is our final answer. We're given this problem right here, 5 over n plus 5 plus 4n over 2n plus 6. And we got to simplify this expression. One thing we notice, our denominators aren't the same. So we have to get the same denominator. So a way to do that, I'm going to rewrite the problem, 5 over an n plus 5 here. And then we have a plus sign. And we have, again, 4n over a 2n plus 6. And a way to do that is to take this denominator, 2n plus 6, and multiply it to the other one right here, 2n plus 6, over itself, 2n plus 6. Because remember, anything over itself is 1. Same thing here. I'm going to take the n plus 5 and do that as well. N plus 5 here, n plus 5. And now we have the same base, or denominator, right? N plus 5 times a 2n plus 6. So now let's go write this as one big fraction. N plus 5 times a 2n plus 6. The numerator, we can combine this, but we're also going to distribute as we go. All right? 5 times a 2n is a 10n, and 5 times a 6 is a 30. From there, do the same thing with the 4n. Multiply it out. 4n times n is 4n squared, and 4n times 5 is a 20n. From there, we're going to simplify where we can. Okay. My denominator, notice that I can pull out a 2 right here. There's a 2 in both parts. So we have an n plus 5 here, and I can pull out a 2, and we have an n plus 3. It's kind of all multiplication there, so be careful. The numerator, well, we can rearrange this. We have a 4n squared, combine our like terms, plus a 10n plus 20n is a 30n, and we have a 30 there as well. Okay, so make sure to bring everything down here. But now, that 2, I think there's a 2 in this numerator, right? We can pull that 2 out of the 4, the 30, and the 30. So in doing that, we can kind of show it like this. Cross that off. This becomes a 2, this becomes a 15, and this becomes a 15. It has to be to all parts. And so with that, we can come down here. We have a 2n squared plus a 15n plus a 15 over our denominator, which is an n plus 5 times an n plus 3. And that is our final answer. We're given this problem right here, 2x over 5x plus 4 plus 6x over 2x plus 3. I'm going to simplify this expression. Well, one thing we need to do is we have to have the same denominator, and we don't. So to do that, I'm going to rewrite the problem, 2x over 5x plus 4, notice the parenthesis here, plus a 6x over a 2x plus 3. And now I'm going to take that denominator, 2x plus 3, and put it on this side as well, 2x plus 3. We're multiplying it. But I have to also put it in the numerator, 2x plus 3. Do the same thing with this 5x plus 4 here, 5x plus 4, 5x plus 4. And now we have the same denominator, 2x plus 3 and a 5x plus 4 being multiplied. So with that being said, we can now simplify more. We can put this all under one big base of a 5x plus 4 times a 2x plus 3. The numerator, we want to distribute this out. 2x times a 2x is a 4x squared, and 2x times a 3 is a 6x. We're adding now, right here. Same thing. 6x times a 5x is a 30x squared, and 6x times a 4 is a good old 24x. Now from here, we need to combine our like terms. In the numerator, we have a 4x squared and a 30x squared. That's a 34x squared. 6x and a 24x is a 30x. Denominator, we have 5x plus 4 and a 2x plus 3. And this actually cannot simplify anymore. And so our final answer here is 34x squared plus 30x over 5x plus 4 times 2x plus 3. We're given this problem right here. 2 over 3x squared plus 12x plus 8 over 2x. And we got to simplify this expression. Well, I need to have the same denominator here to combine them. So I'm going to rewrite this problem 2 over a 3x squared plus 12x, here, a little space, plus the second part, 8 over 2x. But what I'm going to do is take this denominator of a 2x and multiply it to this side, 2x. But I have to put it over itself, like so. Because 2x over 2x is 1. It doesn't really change it. Now to have the same denominator, I'm going to do the same thing with this denominator, 3x squared plus 2x, or 12x. So we have 3x squared plus a 12x here, and the numerator 3x squared plus a 12x. Now that they're being multiplied out, we have the same base. 3x squared plus 12x, and multiply that by 2x. So now our denominator here is the same. Okay, and I'm going to actually multiply that out. 3x squared times a 2x, right, is a 6x to the third power, and 12x times a 2x is a 24x squared. The numerator, we can multiply that out here as we combine it. 2 times 2x is a 4x. And then we multiply the 8 to both parts here. 8 times the 3x squared is a 24x squared. And 8 times the 12x here is a 96x. Keep on going, we're going to be simplifying here. Our denominator, we can pull out a 6x squared. And we're left with an x plus 4 here. So I pulled a 6x squared. I got an x plus 4 in the denominator. Numerator, I want to combine my like terms and rearrange. So the 24x squared is the only thing that's the x squared. But the 4x and the 96x gives me 100x. Now, can I pull out anything in the numerator? And yes, I can. If I pull out here a 2x, I'm left with a 12x plus 50 in the numerator. In the denominator, we still have our, if I can write it here, 6x squared times an x plus 4. That helps me here, so I can simplify this. This x cancels with this x squared, and the 2 and the 6 become a 3. And so my final answer here, which I can write, is just a 12x plus 50 over a 3x times an x plus 4. Don't forget the parentheses. And again, that is our final answer. We're given this problem right here, 7n over n plus 1 plus 8 over n minus 7, and we have to simplify this expression. Well, one thing we notice is that we don't have the same denominator here for the left and the right fraction. So I'm going to rewrite this, 7n over an n plus 1, and we have plus an 8 over an n minus 7. And we need to have the same denominator so we can combine these fractions. So I'm going to take that denominator, the n minus 7 here, and I'm going to put it over itself. Well, why? N minus 7 over n minus 7 is equal to 1. They cancel each other out. It doesn't change anything. N plus 1 here, I'm going to do the same thing. N plus 1. Same denominator here over itself. So now when we simplify this, all right, or we can, we're going to combine the same base. Right? We have an n plus 1 and n minus 7. We can write this as one fraction. N plus 1 times the n minus 7. The numerator, we have to multiply these out. So 7n times an n is a 7n squared. And 7n times a 7 is a 49. We subtract it, n. We're going to do the same thing with the 8 here. We add 8 times n is an 8n. And 8 times a 1 is an 8. So now we want to combine our like terms in our numerator. So we have an n plus 1 and n minus 7 in the denominator. There's nothing else with the n squared, so we have 7n squared. We have a negative 49n plus an 8n is a negative 41n, and we just bring down the 8. And that's it. Our final answer here is 7n squared minus 41n plus 8 over n plus 1 times an n minus 7. We're given this problem right here, 2 over n plus 8 plus 4 over n plus 1, and we've got to simplify this expression. Notice that we don't have the same denominator here for each fraction. So we can't add them right away, but we have to have the same denominator. So I'm going to rewrite this 2 over an n plus 8, and we have a plus 4 over the n plus 1. And to get the same denominator, I'm going to take this denominator, n plus 1, and multiply it here. And I'm going to put it over itself. I then take this n plus 8 here, and do the same thing with the right fraction. We now have the same denominator of an n plus 8 times an n plus 1. So let's go rewrite this now as one big fraction. We can combine it. We have an n plus 8 here and an n plus 1. The numerator, we just multiply this out. 2 times n is a 2n, and 2 times 1 is a 2. Do the same thing with the 4. 4 times n is a 4n, and 4 times an 8 is a 32. From there, we want to combine our like terms in the numerator. So 2n and 4n is a 6n, adding together, and 2 and a 32 is a 34. Our denominator stays the same, n plus 8 and n plus 1 being multiplied. And that's actually it. Can't simplify it anymore. And so our final answer here is 6n plus 34 over an n plus 8 times an n plus 1. We're given this problem right here, 3 over 8 minus 3 over 3x plus 4. We got to simplify this expression. We do not have the same denominator here, so we need to get that. So I'm going to rewrite this 3 over 8 with some space minus 3 over 3x plus 4. And what I'm going to do is take this denominator, 3x plus 4, and I'm going to multiply it by the numerator, 3x plus 4 here, and over itself in the denominator, 3x plus 4. I then take this denominator, which is the 8, and multiply it here over itself as well. Notice now, by putting 8 over 8, it's just like a 1, and 3x plus 4 over itself is like a 1. But we now have the same denominator. That denominator being the 8 times a 3x plus 4. And we now can combine the numerator. So let's go do that. 3 times 3x, let's multiply that out as a 9x. And 3 times a 4 is a 12. Subtracted by 3 times 8, 24. Well then from here we need to simplify this. So 9x can't really combine with anything else, 9x here. But 12 minus a 24 is a minus a 12. And that's going to be over 8 times 3x plus 4. And so this cannot simplify anymore, and so our final answer is 9x minus 12 over 8 times 3x plus 4. We're given this problem right here, 3 over b minus 8 plus 7 over b plus 3, and we got to simplify this expression. Well, we need to have the same base here, okay? Because if we have the same base or denominator, we can add these expressions or fractions, but we don't have that. So I'm going to rewrite this 3 over b minus 8 here, plus 7 over the b plus 3. And I'm going to show you how we can get the same denominator. I'm going to take this denominator, b plus 3, and I'm going to put it on this left fraction over itself. This denominator, b minus 8, same thing, b minus 8 here, and a b minus 8, we're multiplying that out. We now have the same denominator now, b minus 8 times a b plus 3. So we can write that as one big fraction, b minus 8 times a b plus 3. And we now have to simplify the numerator. 3 times b is a 3b, and 3 times a 3 is a 9. Okay. Then from here, we want to do the same thing with 7. 7 times a b is a 7b, and a 7 times an 8 is a 56. Let me subtract that, 56. Make sure I have my spot here. From there, we want to combine our like terms. 3b and a 7b is a 10b. 9 minus a 56 is a minus 47. And we put that over our same denominator, b minus 8 and a b plus 3. And so that's it. Our final answer here is 10b minus 47 over a b minus 8 times a b plus 3. We're given this problem right here, 3 over x plus 6 plus 7 over x minus 2, and we need to simplify this expression. Well, we don't have the same denominator here, so we need to find the same denominator for both fractions. We're going to create that. So I'm going to rewrite this 3 over x plus 6 here, plus a 7 over the x minus 2. And now I'm going to take that base, x minus 2, right here, x minus 2, and I'll put it over itself. Same thing with the x plus 6. X plus 6 added down there, and x plus 6 up here. What this now allows me to do is we have the same base, so we can add these fractions. So we make one big fraction now, the x plus 6 times the x minus 2. And now let's go distribute the numerator. 3 times x is a 3x. 3 times minus 2 is a minus 6. Now we add the 7. 7 times x is a 7x here. And 7 times 6 is at 42. All right. We now want to combine our like terms, and that's mostly in the numerator, or pretty much. 3x plus 7x is a 10x. Minus 6 plus a 42 is a positive 36. That's over our denominator, x plus 6, and x minus 2 here. And this cannot simplify anymore, and so our final answer is 10x plus 36 over x plus 6 times x minus 2. We're given this problem right here, 4 over x plus 1 minus 2 over x plus 2, and we gotta simplify this expression. Notice we don't have the same denominator here, so we can't add the fractions. So we have to now find a way to have a common denominator. So with that, I have my 4 over an x plus 1. Then I'm going to give some space, minus 2 over an x plus 2. But I'm going to take this denominator of the x plus 2 and multiply it here. And I put it over itself. Same with this x plus 1 on this side. X plus 1, x plus 1. We now have the same denominator here, x plus 1 times an x plus 2. So we can write this as one fraction, x plus 1 times an x plus 2. So now let's go distribute this. 4 times an x is a 4x, and 4 times a 2 is an 8. Remember, this minus sign gets distributed as well. Negative 2 times x is a minus 2x. Negative 2 times 1 is a minus a 2. We now need to combine our like terms. 4x minus a 2x is a 2x here. 8 minus a 2 is this positive 6. Denominator stays the same, x plus 1 times an x plus 2. And so our final answer here, it's pretty much it, can't simplify anymore, is 2x plus 6 over x plus 1 times an x plus 2. We're given this problem right here, 5n plus 5 over 5n squared plus 35n minus 40 plus 7n over 3n. And we got to simplify this expression. Well, first I'm going to see what I can break down here for each one. So I have 5n plus 5. Well, I'm going to pull a 5 out here, and I'm left with an n plus 1. Denominator, I can pull a 5 out of each part here as well. I pull out 5, and I'm left with an n squared plus a 7n minus an 8. Now we have 7n over 3n. Well, the n's just cancel, and we have 7 over 3. And here, actually, the 5's cancel too, right? So we have n plus 1 over n squared plus 7n minus 8. Now here, that looks like it can factor. So we have an n plus 1 in the numerator over, and what two numbers multiply to be negative 8, but add to be a positive 7, and that's a minus 1 and a positive 8. And then we have a 7/3. Now this looks a little easier for us to, well, combine. We still need to combine these fractions by having the same base. So what I'm going to do here is rewrite this, okay? Again, we have the n plus 1 over n minus 1 times n plus 8. Give myself a little space here, plus 7/3. But I'm going to take this third, that's in the denominator, and multiply it here. Put it over itself. This other denominator, to n minus 1, n plus 8, do the same thing here. N minus 1, n plus 8. And we have n minus 1, n plus 8. Now from here, we have the same base. So we can combine this as one big fraction. We have a 3, put it out front, n minus 1, n plus 8 here. The numerator we need to distribute. N times 3 is 3n, and 1 times 3 is 3. Same thing here, okay? Now, notice we know that n minus 1 times n plus 8 was right here. So I can give a little note to myself like this. N squared plus 7n minus 8, like that. Because we know they're the same, and we already found that out. And that's going to help us when we distribute, like there, okay? So 7 times n squared is a 7n squared. 7 times a 7n is a 49n. And 7 times an 8, subtract, we got a 56 here. Okay? So now we want to combine our like terms in the numerator. We only have 1 with an n squared, so we have 7n squared here. Okay? We have a 49n and a 3n, add to be a 52n. And a 3 minus a 56 is a minus a 53. And that's all over 3 times an n minus 1, n plus 8. And this actually cannot simplify anymore. And so our final answer here is 7n squared plus 52n minus 53 over 3 times n minus 1 times n plus 8. We're given this problem right here, 3 over n minus 5 plus 6 over 3n minus 8. And we got to simplify this expression. Well, we want to have the same denominator here, and we don't. So I'm going to rewrite this problem, 3 over n minus 5 here, give myself some space. Same thing with the 6. 6 over 3n minus 8, give myself some space. I want to take that denominator, 3n minus 8, and I'm going to put it over here, 3n minus 8, and I'm going to put it up top here, 3n minus 8. This doesn't change a fraction, alright? So 3n minus 8 over 3n minus 8 is still 1, but it's going to help us get a common base. Do the same thing with the n minus 5 to this part. N minus 5 over n minus 5. We now have the same denominator, n minus 5 times 3n minus 8. So write that out, n minus 5, 3n minus 8 here. And now the numerator, we want to distribute this out. So 3 times a 3n is a 9n, and 3 times a minus 8 is a minus a 24. Same thing with the 6. 6 times, it's a long, it looks like an extended 6, like a swooping hair. 6 times n is a 6n, and 6 times a minus 5 is a minus 30. So there we want to combine our like terms here. 9n and 6n is a 15n, and then negative 24 minus 30 is a negative 54. All of that is going to be over an n minus 5 times a 3n minus 8. This cannot simplify anymore, and so our final answer here is a 15n minus 54 over n minus 5 times a 3n minus 8. We're given this problem, 25 over 4 over 1/5 minus 4 over 25, and we gotta simplify this expression. Now this is a doozy of a problem, lots of fractions, but we can do it. Let's start small, start with this right here. So 25 over 4 over, I want to have a common denominator here, and I see a 25, and this is just a 5. So if I multiply this by 5 over 5, we then have a 5 over 25 minus 4 over 25, and now we have a common denominator. So we can simplify that a little bit. So we have 25 over 4 stays here, and then 5 over 25 minus 4 over 25 is a 1 over 25. Well, the way I see these division problems, I see them as multiplication. We have 25 over 4, and instead of dividing 1 over 25, we can multiply by the flip of it, 25 over 1. And if it's easier for you to see, 25 over 4 divided by 1 over 25, you can see that flip here with multiplication. Now it's not too bad. 25 times a 25 is 625. 4 times 1 is a 4, and we're basically done. Our final answer here is 625 over 4. We're given this problem right here, 8 over 4 divided by 9 plus 16 divided by 9, and we gotta simplify this expression. Well, luckily for us in this denominator, they already have the same base with these two fractions. So the top stays an 8, but 4/9 plus 16/9 is a 20. 4 plus 16 is 20 over 9. Now, we have a fraction here and a fraction. So many fractions. What I like to do is I take that 8, instead of writing it over 20 over 9, write it like this, divided by 20 over 9. I think it's easier to see. Then, I turn it to multiplication. Instead of dividing 20 over 9, I multiply 9 over 20. Remember, we can flip the fraction to make a multiplication. This makes it a little easier to see. Okay, now let's go simplify where we can. 8 and the 20, both are divisible by 2. So we have 2 becomes a 10, and this is a 4. Oh, both divisible by 2 again. 5, and this is a 2. Okay? So now we simplify that out. 2 times 9 is an 18. And we still have 5 in the denominator. 5 right there. And so our final answer here is just 18 over 5. We're given this problem right here. A over 25 minus A over 5 all over A. And we got to simplify this expression. Well, I want to deal with my numerator first, the main big fraction. And I have to combine these, but I have to have the same denominator. So I'm going to take this right-hand side right here, and it's a 5. And I'm going to multiply it by 5 over 5. And we'll see what happens. We have A over 25 here, minus A times 5 is a 5A, over, and 5 times 5 is a 25. And we're still over this A that's down here. And what that did is gave me the same base here, which allows me to combine that fraction. All right, so again, another arrow. By having the same fraction, same base, we have 25 here, and then A minus a 5A is a negative 4A. But all that is over that 1A down here. Be careful with our fractions. Well, to make it easier to see, this is what I like to do with our division here. Negative 4A over 25, I'm going to write like this, 4A over 25. And instead of the bar for division, I'm going to write like this, divided by A. That might make it easier to see. So we have negative 4A over 25, and instead of dividing by A, really A over 1, we multiply it by 1 over A. We can flip that fraction. And what that does allows us to cancel the A's out here, and there's nothing really left. There's just a 1 on the left, on the right-hand side. So we have a negative 4 over 25 left over, and that's it. That is our final answer. We're given this problem right here, 5/4 over 5m minus 4m, and we need to simplify this expression. Well, what I want to do is I need to find common bases and combine those fractions. When we have that right here, our bottom fractions here, we have the same denominator, which is an m. So we can combine that. So we have 5/4 here over, well, we can write this as one fraction with our one base, denominator, m, and 5 minus 4 is a 1. So now we have 5/4 divided by 1 over m. Let's go write it like this, 5/4 divided by 1 over m. And we know with division here is the same as multiplication if we flip the fraction. So we have 5/4 here times m over 1. And now with that, we can easily multiply this out. 5 times m is a 5m, and 4 times 1 is 4. And so our final answer here is 5m over 4. We're given this critical thinking question. We need to simplify a over b plus c over d. Well, to combine these fractions, we have to have the same denominator. So what I'm going to do is I'm going to rewrite this a over b with some space plus c over d with some space. Now, to have the same denominator, I want to have a denominator that's b times a d. So I'm going to take that base d, multiply it here, but I also have to multiply it to the numerator because I can't really change it up, the essence of it, because d over d is just a 1. Same thing with the b. Multiply this by b, multiply this by b. Now, we can combine these as one big fraction. We have a b, d in the denominator, b times a d. In the numerator, we have an a times a d plus a c times a b, and that's it. Not too bad, but we simplified, and our final answer here is AD plus CB over BD. We're given this problem right here, 2x plus 3 over x squared plus 3x plus 2, and we need to split into a sum of two rational expressions with unlike denominators. Kind of tricky here. First thing I'm going to do is, well, I'm going to look at my denominator, and I can see I can factor that. That's going to give me a good base here. All right, so we ask ourselves, what two numbers multiply to be a 2, but add to be a 3? And that is a 1 and a 2. X plus 1, x plus 2. That is how we can factor our denominator. Now our numerator. Well, 2x plus 3, what can we do with that? Well, notice if I add an x and an x, I get 2x, and 1 plus 2 is a 3. Kind of already found that. So I can write my numerator as an x plus 1 plus an x plus 2, right? X is a 2x, 1 and 2 is a 3. And now watch this. We have the same denominator, right? The x plus 1 and x plus 2. I'm going to break this into two different fractions. It's kind of like reverse of what we've been doing. We have the x plus 1 times an x plus 2 right here. Plus, I'm going to do it again, x plus 1 times an x plus 2, like that. But our numerator, I'm going to write just x plus 1 up here, and I have an x plus 2 right here. And notice, it's still the same thing we've been doing, it's fine. Still the same expression, but watch this. We cancel the x plus 1 and this x plus 1, cancel this x plus 2 and this x plus 2. And so, to make it fit over here, I'll write what we have. We have a 1 over the x plus 2 in the denominator here, plus 1 over the x plus 1, and we have our final answer. What they told us, we split this sum into two rational expressions with unlike denominators. It's still simplified, still the same expression here, but our final answer is 1 over x plus 2 plus 1 over x plus 1. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.